Hi everyone, welcome to the Digital Fashion Network webinar series. Thank you for attending today's webinar on the digitalization of textiles. My name is Abu Saim. I work at Manchester Metropolitan University in the Manchester Fashion Institute, and this webinar is being organized as a part of our AHRC or Arts and Humanities Research Council network project, the Digital Fashion Network. Before we begin, I just want to cover a few housekeeping items with you. First, we love an engaged audience, and as you can see, we have got an Q&A section on the screen, as you can see. So feel free to get engaged and write as many as questions you have. We love questions, and our presenter will be happy to reply or answer as many as questions you have. But in case we run out of time, we will get in touch with you by email in a later time. And also, as you can see, we have got also the chat options open, same as the Microsoft Teams regular meeting. So feel free to use this option, try to network with others. And just to get the ball rolling, if you just want to drop a line where from you are joining us today. I'm live from Manchester, and our speaker Gabby has joined us from London. Now, let me introduce our speaker, our presenter to you today. Gabrielle leads the technology adoption and quality development of Bureau 555 and has worked in design and manufacturing over 20 years. She brings with her a background in training designers and product developers on software to simulate fabric. Gabby previously held the post of course leader for the BA Honours Fashion Buying and Brand Merchandising course at Ravensbourne University, London. And she is the founder of Shiner-Hill Design Consultancy. She is trained in textile design at Central St. Martin's. Sorry. Through her company Bureau 555, she helps brands and manufacturers create high quality 3D samples by utilizing fast digital workflows so they can reduce their lead times, cost and waste. Gabrielle will talk about how she and her company are working with the supply chain to create digital twins of textiles and what makes a high quality digital material. So without any further ado, I'd like to pass it over to Gabrielle. Gabby, over to you.
Hi, thanks so much. Thanks for the introduction. Hello, everyone. Right, I'll just share my screen actually while we're here. Let's just double check that's all working. Just checking you can see that. Yeah, nodding. Okay, fantastic. Well, good afternoon, everyone. Yeah, I'm coming from London. So it'd be nice to hear where everyone is from today. I'm going to give you a bit of a background on myself and the company, and also talk about examples of how materials are used in how our digital materials are used in the industry, some of the challenges we're facing, and then some of the solutions that are coming to market quite currently at the moment. So I guess I will crack on. Let me just make sure. Okay, just a quick introduction to myself. So yes, I'm Gabby Shiner-Hill. I'm a trained weaver by trade. So I graduated back in 2001 in textile design. And then I mainly worked in the supply chain. So I was working for suppliers like David Howard, Esquel and Dewhurst. So for the UK audience, you might know those quite well. But during that time, I also worked for a software company called UKRI, which is a CAD design system. And part of my role while I was working at UKRI was to travel around America and go into the mills in the North and the South of Carolinas and teach the mills how to digitize their design process. So this was back in 2002, 3 and 4. So it was quite early on in the digitization process. And it gave me a real interest in how we could find quicker ways to work, how we could use digital technologies as tools to support us in our industry. And also, because I was working directly with the mills, it allowed me to kind of see the reality of what it is when you're obviously weaving and producing material. in an industrialized environment, as opposed to sort of sitting in an office and designing something lovely on a computer and then hoping that it turns up the way you expect it to afterwards. So having that on-ground experience in the mills really helped. And then when I was working at Esquel and Dewhurst, I was traveling a lot to the mills and the manufacturers. So Esquel was a vertical manufacturer, so we had all of our own garment making and all of our own weaving and knitting. But at Dewhurst, we were like a traditional supplier. So we were literally sourcing materials and sourcing the garments to give them back to the buyers. So again, during that process of working at Dewhurst and Esquel, I had to sample a lot of garments. We were supplying people on the right, for example. So Marks and Spencer, well, Esquel was like Tommy Hilfiger, Ralph Lauren and Burberry and Calvin Klein. And then at Dewhurst, I was supplying Marks and Spencer's and Next and Fred Perry, all names you'll be very familiar with. So while I was working with these companies, my job was obviously to sample the garments. So fully embedded in the supply chain. And what I would do is I discovered obviously that the hit rate of our samples was pretty low. So for example, I would develop 10 samples and maybe one would get bought. And no, it hasn't changed that much, right? We're developing a huge amount of garment samples, but only one or two might be bought from that hit rate. So this sort of set me on my path to thinking about how we could reduce the sampling within the supply chain. And that was back, I left Dewhurst actually in, 2016 to set up my consultancy. Then I went to work at Ravensbourne, where I was working on sourcing and sustainability and considering more, right, how could we reduce the textile waste during our sampling process? While I was at Ravensbourne University, we also embedded Clo in the fashion design course. So that was the partner course I was working on. And we worked with the fashion design course. And in the fashion buying course, we also thought that Clo would be a really good idea for our students, because if we were going to train the buyers of the future, we wanted them to be able to understand and visualize products digitally. That was really important for us. So during the pandemic, we got our students using Clo, and I began to obviously see the real tangible outcomes that could be had. While I was working at Ravensbourne, at the same time, I was consulting with a fabric mill in Bangladesh called Hamid Fabrics. And my now business partner, Nusrat, reached out to me and we were talking about digital materials because we couldn't send our materials anywhere during that pandemic. So she reached out to me and said, well, why don't we build a virtual showroom? And we're like, excellent. We're going to build a virtual showroom. It's going to have all of our beautiful materials in it. We did that for, I think it took us about 2 months. We partnered with a Hong Kong-based company who were really good, and they developed a fantastic showroom for us. But the problem was the textiles in the showroom looked terrible. The resolution was really poor, so the fidelity of the materials looked really bad. They didn't drape the way textiles did. And from myself coming from a textiles background and from my business partner Nusrat coming from a textiles background, you really couldn't see how this could be adopted by us, let alone anyone else in the industry. So we put our heads together and we researched for about 9 months. And then we opened our company Bureau 555 with an aim of researching and specializing in the digitization of materials, really to solve our own problem before we even got to anyone else's problem. And our own problem was our digital materials didn't look good enough. So that's, in a whistle-stop tour, how we got to where I am today. So, and if you've got also, please, if there are any questions while I'm going through, I can see the chat. So just feel free to just pop them in there if there are any questions at all. This will last for about 25 minutes and then there'll be time for questions at the end as well. So I've given you my background and here is some of our team members on the screen here as well. And this is Nusrat, my co-founder, my business partner. So she's based in Bangladesh. I'm based here in London and our team is based in Bangladesh as well because we've embedded ourselves in the supply chain because we knew that if we were going to start scanning materials, so scanning physical materials that existed and making digital twins of them, which is essentially what we do, we couldn't then be sending those materials all over the world to then get them digitized. That didn't make any sense because we'd already been sending the physical samples everywhere. So we're now going to send the samples everywhere to get them digitized. So we decided to set up in Bangladesh and digitize the materials there. So as the materials come in to the manufacturers, that's where we digitize them, or we take them directly from the mills if they're being bought directly in Bangladesh, or they're being made directly in Bangladesh. So Nusrat's background is director of Hamid Fabrics. So she has been working in a woven textile mill for over 12 years, yarn dye, piece dye fabrics. So she really understands the needs of the mills and the supply chain. She also has a background in marketing and is co-founder of an art foundation, Brahata. So we set up our company creating digital twins of materials. So digital twins of physical materials that exist. We do also now make digital only materials from CADs or made in substance as well. But our main remit for the supply chain is to make the digital twin of the physical material they have, so that that fabric can be given to the manufacturer and the manufacturer can make the 3D sample. So our aim of our company is to make these digital technologies accessible, because we don't come from a completely digital background. I, yes, have a huge amount of interest in how technology can support us, but we haven't built the technology ourselves. We are using the technology that is out there. So we're not developing the technology at all. We're using market available technology. We're trying to support the brands, manufacturers and mills to work towards a more sustainable and resilient future, because we know that the oversampling can't continue. We are material first, which means for us that we have the material knowledge first. So we have the textiles knowledge first. So instead of being digital technology specialists who are trying to understand what textiles need to look like, we know what textiles need to look like in 3D, and then we try and fix that by working with the technologies available to us. So the people that we work with at the moment, so customers that we had through the door is PVH, obviously with digitization. So Tommy Hilfiger and Calvin Klein have done we're a scanned service provider for them out in Bangladesh. We've worked with Next and Etam and Marks and Spencers as well. And we've done a lot of work in the education side as well. So we've worked with the V&A and the British Council, Butex out in Bangladesh, Dhaka University. We're doing some work with Arts University of Bournemouth, which I will talk about later, and also with UAL through some funded grants for material digitization. Because as we know, this is a developing space. There's not an easy way. Well, there are some easy ways of doing it, but there's not a clear-cut workflow right now. So I'm going to ask you a question, and you have to scan. You can get your phones out and scan this QR code, and you'll be taken to a little poll. And I'd like to ask you, which picture is the simulation? So what this means is you're looking at two pictures of the same fabric. One is a photograph of a physical fabric, and one is a digital simulation of the same fabric. And I'd like to know which you think is the simulation. So please do scan that QR code with your phones. It should just come up. I'm asking you this not because I'm trying to trick you, or because I'm trying to even actually convince you that one of them is digital and one of them isn't. Maybe I'm playing a trick, but I'm not. I promise you, one is digital, a digital image of a fabric, and the other one is a photograph. But I'm asking you this because we're going to be looking at in this talk about what makes a digital material. Because a flat photograph or a photograph of a fabric, or an iPhone photograph of a fabric, or even just a flat scan with no other technology of a fabric does not make that a digital material. There are many other things that need to be added to that digital file to make it a digital material. So I'll give you just a second. I can see a couple. I've actually got the poll up here, and at the end I'll tell you which one is which. I promise I will actually tell you. But I can see that you guys are putting your responses in now. Okay, I'll move forward now. So I explained this really quickly. So why are we trying to create digital materials? Why do we think that's important? And why do we think the supply chain should start digitizing their textiles? Our real aim is to reduce that textile waste within the sampling process. But I'm going to talk to you about where our digital materials are used, because we came into this company saying, right, we want to reduce down sampling. That's what we're looking at doing. But what we've also found is our materials are being used in lots of other spaces, which is what I'm going to talk about. So our aim was to reduce down the sampling so that we could stop, actioning lab dips, actioning fabric yardage, shipping samples from country to country, and also having to have a lot of physical approvals and sign-offs. So all of that associated textile waste generated from the fabrics and the garments that never go into production, they may end up in landfill, they could be used on a secondary source, and also all of the transportation that's used just shipping back and forth. I think I'm talking also to an audience that would understand this, but we know within the sampling process that if you request a sample from a manufacturer, they're not just making one, they're making a keep sample for themselves, they're making one for you, and they're usually making one for a buying office as well. And that's just for the first sample you request. And then you're going through to protos and seals and salesman samples and press samples. I think you guys as an audience understand this. A lot of people don't, but we know here that I think everyone does. So we did some investigation and we looked at some figures, and one report that has come out does show that there is a 96% carbon reduction when you go from digital sampling compared to physical sampling. So that's taking into account the processing and the CPU usage of a digital material. It's actually based on a cotton poly athleather shirt, as opposed to this seersucker that you see in front of you. But we know that there's clearly a carbon reduction potential, let alone the reduction in chemicals, water usage, and labour. So I'm going to flick through this. We don't really need this. But the main points that we do as a business is we do the digital twins, 3D material digitization. We do 3D garment visualization. And then we also do validation, which means that we support companies to validate their digital materials when they're starting out and do training programs as well. But I want to move on to this is the uses of the digital fabrics and where we're seeing digital fabrics being used. So the little stars that I've put here are where our company's digital materials are being used right now. So if we think about DPC, digital product creation, our digital materials are being used for 3D product visualization. So that is internally in-house. Our materials are taken, they are used by the manufacturers to make the 3D garments, or the brand is making the 3D garments, and then the brand is developing their range from those 3D garments. So they are being used for 3D product visualization. Virtual fitting is happening. It's not happening particularly with our materials at the moment. It's possible, but the feedback that we're getting is it's not mainly happening with our materials at the moment. Rapid prototyping, so quite a lot of print placement, embroidery placement, and different sizing of designs. That's where our materials are being used. You can use it for production planning and sourcing, but also our materials are being used in costume and archiving. So not with the supply chain, but I've added this because it's really important thinking about fashion and historical fashion and archiving, but our digital materials are also being used for archiving processes as well. Within marketing and sales, our materials go all the way through. So they go through past Clo and Browseware, and they will then go into maybe a software called Keyshot for e-commerce. So when you look on some of the websites, you will see digital garments being used instead of the physical photography that we're used to. So our digital materials go all the way through to e-commerce, but they can obviously be used in exhibitions, digital showrooms, social media, and digital content. And then let's not forget, obviously, on the metaverse side for the gaming and the AR and VR and extended reality, digital only product and digital products. So our materials aren't used in this space right now. We have made materials that have gone into VR spaces. We've made materials that have gone into AR spaces. However, with our customer base right now, just explaining that they're not being used in that area at the moment. So how are people using digital materials right now? Where are digital textiles appearing within the supply chain? So this is where we're seeing the real industry application. So with garment manufacturers, what happens is and I've just given some images here. So what happens is we receive the material in our offices in Dhaka. Bottom left-hand corner, you can see we'll scan that material. We use a number of different scanning technologies. This one is Visu X-Tex. So we scan the materials. We then, if you go to the right-hand side, we then test the materials. Either if it's for Browseware, we use the fabric analyzer, or if it's for Clo, we use ISO testing methods. We then package up that information into one digital file, and in the top right-hand corner, you can see that being QC'd. And then we deliver that material back to the garment manufacturer. It's a digital file. And it's usually delivered through their PLM system or another system that they're using. And then they download that and they make their garment, their digital garment. So the companies that we're working with right now and the garment manufacturers that we're working with, which is about 8 in Bangladesh, are all digitizing their core materials. So those materials that are being used time and time again each season. If we look at a customer like PVH, you know, you're looking at maybe 65% of their product is core running through each season. So that's where the materials that we're digitizing. If we look at the textile mills, so we're only working with a couple of textile mills at the moment. Textile mills are under a huge amount of pressure. Resource-wise, financially, it's a really, really tough time. But one of the textile mills that we're working with has digitized over 400 of their materials, which means that the brand can go in and select the materials, download them straight away, and then start making that and do their 3D prototyping straight away without having to select samples and everything like that. And then how are we working with the brands? Well, the brands are almost a conduit for us. So we work directly with some of the brands, doing research projects and doing small digitization projects. But our main digitization role and revenue comes from the manufacturers and the mills, because the brands are actually starting to push out the digitization process. So what was happening in-house is now moving into the supply chain. And just as a reminder, we are specifically working in Bangladesh right now, but this is happening in other countries as well. So we happen to be region specific, but you can see it obviously happening in China, it's happening in Portugal, it's happening in Turkey, right? So it's not like it's a completely unknown set of workflows that are running through right now. So the main activities that we have is material digitization, the testing for 3D technologies, the validation, the training of the supply chain, and any extra digital processing. So we might do scans and repeats for some customers. Not all customers want like fully tested materials. They just want like quick, really high, like quick, high quality digital materials without all of the testing. We do that as well. So this is the actual workflow for digital materials for brands and manufacturers. So hopefully this is helpful and gives you a bit of a sense of an idea of how it can work directly in industry. So if we start on the left-hand side, so you can see three different logos there, Bandicoot, Visu, and Epson. So those are the three different types of scanning hardwares and inputs we use. So Bandicoot is photography based. It's a really interesting piece of software that you photograph like 25, you take 25 photographs of your material, and then the Bandicoot imaging compiles that together into a digital material for you, and then it downloads, you can download all of your maps to make your 3D garments. So we use Bandicoot, which is really good for lots of different materials, but very complex materials like velvets, really good for denims, really good for large scale as well. We use Visu, which is pretty industry standard. There are lots of Visu scanners in the supply chain. So Visu has had really good market penetration into the supply chain, which means that it's sort of seen as the best industry standard. Drawbacks are that it's the size. You've only got an A4 or an A2. A2 is very, very expensive. A4 is not cheap, but the A2 is very, very expensive. So it's quite small. It doesn't work for all industries. I know with Digital Fashion Network here, but large repeats are an issue. Let's talk about, and also if we're talking about home furnishings, which we also do home furnishings as well, that doesn't always work. Or Epson as well, which we use with some of our other 3D softwares. We don't use the Nuno X scanner currently, and we also play around with some of the AI generated fabric scanning options like VMod. But right now for the industry, these are the three that we are using and are verified workflows. So we scan those in-house. Then we test the material and we add the fabric physics to that digital file. So it's the data that we're adding in. And then we upload that digital file with any associated data, maybe the master data as well, if it's requested by the brand. And we put that either onto the DMIX platform, which is a German end-to-end solution, which we use quite heavily, or into their own PLM system. And then that means that the fabric is then available to be downloaded by the brand's ecosystem of suppliers and vendors. At that point, the manufacturer downloads the material, creates their 3D sketch, uploads it back to the brand, and the brand puts it into their virtual showroom. So that's the process that's happening there. And everything you see from the images that I'm showing you today that aren't photographs are digital materials that we've made or digital garments that we've made. So that's how we work with the brands and the manufacturers. And that's the current accepted workflow. But how are we working with mills? So for mills, it's a little bit different because with the manufacturers, the return on investment has been shown, right? We can, if you go to Browseware and you talk to Browseware, they will give you a really fantastic calculations around return on investment, right? Same with DMIX and lots of the other technologies. But the mills are outliers in this landscape right now, not because they don't maybe want to digitize, but they haven't really been brought into the conversation at this point in time. So the mills that have digitized generally have been quite forward thinking because they've had the requests from the brands. Because again, some of these more just a more sort of like time intensive process, you're only going to start on that process if you're being requested by your customers. And from conversations maybe 6 or 9 months ago with mills, customers weren't requesting digital materials at that moment in time. However, now we're working with some mills who are having that request, then they want to deliver digital materials. So this is the way we would work with them. Again, 3 different scanning options. We generally use the best scanning. We try to use the right scanning to give us the best output. So it could be that we use the Visu, majority is Visu, but we use Bandicoot as well. We use Epson as well. So it depends on kind of like the output we're looking for. So again, we'll do the same thing. We'll receive the fabrics at source. Now here, and we'll talk about it in a little bit, is we are receiving fabrics now in the UK and Hong Kong and Bangladesh. So we've expanded where we can receive fabrics, especially to help the mills. Then we're adding the fabric physics and doing the testing, obviously. Then we upload the fabric file onto DMIX, and then the mills customers can browse and download the fabric for use. So it's literally a live database where you can see all of the materials in 3D, and then you just click on a download button and you get either your Browseware file or you get your ZFab for Clo, and then you can make your garment. So obviously, as an option for mills to offer that to their customers, it's pretty high performing to offer that. But it also, as textile people, it makes sense because the mills are creating the materials. Therefore, I would argue they should have the digital ownership of the materials as well. I'm going to talk about ownership because it's a bit of a tricky subject within digital, because who owns what? We'll talk about that in a second. But I would argue that the mills should have that ownership of their digital material because they have made the material themselves. However, if we look at the way we're working with the brands, we're not getting those materials directly from the mills all the time. So we are digitizing materials that don't necessarily come from the mills. It's a classic, supply chain moment. So where are we kind of doing all of this right now? So, we've only had our doors open in February. It'll be 2 years. So our customers are mainly based in Bangladesh. We have some customers in the UK, one customer in India, and a couple in America as well. But obviously we're based in the supply chain and we've focused our activities there. So most of our customers are in Bangladesh. We have an office in Dhaka in Bangladesh. We have an office in Hong Kong, and we have an office in London as well. And we have technology partners. So we have gone into partnership with some of our technology companies. So we're working really closely with DMIX. We're working, and we have a partnership with them across the UK and Bangladesh. We're working closely with Visu as we're going in for certification and should be certified by them hopefully in the new year. And we work really closely with Bandicoot, working with their system and also doing some back-end work around tiling and repeats as well with them. So softwares, we have quite a broad range of softwares that we use. And here I'm showing them. So as I said, DMIX, we use Swatchbook as well for asset management. So DMIX is our main asset management system, but Swatchbook is another asset management system. We don't use them as much, but they are out there. Visu for scanning. Obviously we use, Figma's for design work. Bandicoot is for scanning work. Creative Cloud, fine. Substance, so we use Substance Sampler. Quite often we find with some high performing digital customers, they want the maps re-edited in Substance and sort of almost like tweaked and post-processed because they're usually taking their materials further than just Clo or Browseware. If you're just going to be rendering your garments in Clo and Browseware, maybe then like a basic level of rendering is okay. But if you want to have really sort of like high resolution, good fidelity digital materials, then you'll be working in Substance as well. We also do work in Blender. Quite a lot of our customers ask us to quality control in Blender. So we'll take those materials into Blender, we'll look at them. Blender is free. I don't know if people use it on the call, but Blender is free. It's not easy to use, but it's quite good to use for the quality control as well. We use Cinema 4D for animation. We held off animating our materials for quite a long time because we had to focus on getting the actual digital material correct. And in the last 4 months, we've been looking at animation. It's a whole nother kettle of fish. It's a whole nother ball game for animation. And we do work with partners as well with that. And then internally, we use Browseware and Clo to make the 3D garments. So we don't use Style 3D at the moment. We don't use Optitex. We deliver files for those softwares, but we don't have them internally for quality controlling at the moment. And quality control is quite a big, is obviously a really big aspect of what we do. And you can think of it like the same level of quality control that you would have with producing a physical fabric. We have to quality control it at every stage, whether it's for color, whether it's resolution, whether it's for repeats. We then have to take it into different softwares. It's almost like we're trialing it in different softwares. We have to take that material into different softwares, test that it performs the way we expect it to. So we kind of use all of our applied textile knowledge from the physical textile world in the digital world. It's very, very, like process-wise, it's very similar. So some of the impacts we've had. So to date, we've scanned over 3,500 fabrics, and we have created 3,500 fabrics, which have been given out, which has saved, if those fabrics were going to be made into 30 meters of materials, which is quite often the case. So we've saved around 105,000 yards of textiles, which equates to about 1.5 million kgs of CO2 approximately. 1.5 million kgs of CO2 doesn't mean much to me, so I stuck it into a calculator, and that's the equivalent to driving 407 times around the world. So it's a good amount of carbon reduction potential that we can show with digital materials and digital sampling. So what are the challenges? There are a lot of challenges. It's not like it's a walk in the park. It's not really easy. Some of the key challenges we've seen and come up against is cost of hardware and software. So we know that these hardwares and softwares are expensive. We also know that the technology companies build in maintenance contracts because that's how technology companies work. I have worked for technology companies before. You can't develop your software if you don't have revenue from maintenance coming through. So you've usually got quite heavy maintenance contracts to help develop the software, and you need to develop the software because the technologies are moving on so much. If you want your software, if you want your digital file to talk to another piece of software, maybe it doesn't at the moment, but that piece of software might develop an integration, which means that it does in the future. You need to be upgrading your software and making sure you're working on the most recent versions so that you're performing to the best of your ability. We've got learning curves and pipeline of users. What I'm doing is I've got a video playing at the same time, which is just showing some of the work in Blender, which just shows some of the digital material work we do as well. So learning curves and pipeline of users. It is a really steep learning curve. I would say we've had a luxury in our company of being given some grants to develop our team because we had to develop our team from scratch. So we have trained fabric technologists to be digital fabric technologists. That's how we work. We take textile specialists and train them digitally as opposed to doing it the other way around. And that's given us the best result. We've done it both ways and we still get the best result from training textile specialists on digital technologies rather than digital technology specialists on textile technologies, on textiles. Pipeline of users is really tricky. We've got quite a lot of design graduates coming into the UK with 3D skills. And I'm sat talking to manufacturers in Bangladesh who are really struggling to find designers with 3D skills. and new recruits with 3D skills. So we're working really closely with the universities in Bangladesh to try and support them to develop the skill set there. New technologies entering the market. We've had to but we've had to make a decision on the technologies we're using, and we do bring new ones in, but it is quite tiring with all of the new technologies coming on. But we have to investigate them, we have to look at them, and then we choose, do we adopt or do we not? Do we wait or do we partner with someone that's using that technology? Because we cannot do everything. We cannot do you cannot become skilled in every single software. Change management, working with the manufacturers and brands and mills for them to understand that the digital workflow is here, it's ready, and it's coming already. So that is making people understand, obviously, that those digital technologies, that these digital technologies exist and are being used already is quite a big barrier for us. Interoperability. So if we make a file for Clo, can it be used in Browseware? Can we convert it? Obviously, this is what we work on, but interoperability between two different softwares, it's really tricky. You know, a U3MA file format, which is what you're going to be using in Browseware and Optitext, doesn't open in Clo. We know this, right? So that is a challenge. Large scale material capture. What if your repeat's bigger than A4? There's lots of repeats that are bigger than A4 out there. Color calibration. What is the answer for calibration? I preface this by saying I do not have the answer. I'm not a color specialist, but color calibration for us is really clear. We work on spectral data through DMIX, which means that if the physical textile is made, it is completely monitored through spectral color data. So what you see on the screen is your pink, it's your Pantone in front of you, and what you get for your lab dip or what you get for your yarn dye will match that. What you see in between digitally will be close to it, but color calibrated screens between manufacturer and brand is pretty rare. Current research that we're looking into, and lots of other people are looking into as well, is industry standards and workflows. Is how can we have some clear industry standards that can be followed? There's lots of PhDs out there that are being done on this. There's I read all of them. I look to see what's being done, and if anyone is doing one now, please let me know. We love to see it when it's given out. Ownership of digital assets. Who owns these digital assets? Within our very opaque supply chain world that we live in, ownership is already quite intangible, shall we say. So when we start to talk about ownership of digital assets, you know, people start kind of getting a bit uncomfortable, but it's something that needs to be thought about. It's something we're investigating. And cloth simulation as well. So cloth simulation is still not, it's not perfect. It's getting there, but it's not perfect. So who's out there and doing some things that could maybe help and support us, and some solutions that are definitely on the market. So Vizu just released the other day, I think it's like 2 days ago, they released a press release where they're doing conversion. So if you test your fabric for Clo, there's a physics conversion tool which will give you the data for Browseware, the physics testing data for Browseware. So that's really interesting, and vice versa. So we've looked at that, which is really, really interesting. Then I put DMIX on here because of obviously the color management. Color management is such an issue, but if you're using spectral data, that's where you need to be. And then for Bandicoot, I put in the large scale scanning, which is super helpful. You know, real problems that we have that are being solved by solutions that are on the market right now. So just coming towards the end, so key elements of a high quality digital fabric for digital product creation. So we consider there are 3 aspects of this. You've got the appearance of the material, the way it looks. That is all the texture maps that are in the material as well. You've got the physics. So that is the bending, the elongation, the weight and the thickness. And that will obviously be, the physics will determine how your material moves in the 3D environment. So that's really important. And then you've got the master data. So that is all that information around your material. So you've got obviously, you know, composition, yarn count, GSM, fabric type, all of those things. But you can also be adding in and capturing the impact data. So carbon footprint, certifications, water usage. So imagine if you're working with a mill that gives you a digital asset at the very beginning that is visually and physically the same as your physical fabric, and it has all of the data that you need to do your impact reports as well. This is the day when we'll be so thrilled and happy, we'll be jumping up and down. But this is, for us, the key elements of a high quality digital fabric. And this is where it's going. This is what we're doing for like a small selection of customers. We're doing this, but this is where the industry will be going, especially as we have to report on all of our impact. So if you can have it from the beginning, from the mill, that is would be amazing. I was quickly going to talk about maps. I think, so I'm not sure of the awareness of the audience or of how much people have used these softwares, but just quickly explaining that digital materials are made up of these layers, and these layers are actually, they tell the software how that material looks and reacts under different lighting environments. So if you get the maps right, that's when your material looks really good. And each map is a different signifier of that material. So for example, the base color is what would be like almost like a flat scan of the image. It's what you visually see color wise. And then the normal map you've probably heard of, it's the bump map. So it gives it kind of the texture of that material. Combine that with the displacement map for the height. And then you're getting like a more greater depth of material. The metalness is how much it reflects, the material reflects its surrounding. Roughness map is how rough or smooth it is. And then the alpha map is transparencies. There are other maps that can be added in, but all of these maps pulled together will make the material perform in a 3D environment. You can't sort of take one out or not have one of them. You have to have all of them, like think of it like a cake. You have to have all of them together. And I thought it'd be helpful as well just to have like key product areas that we're doing the digital materials for, and also then the digital garments, because not every product area right now is lending itself to digital materials. So we don't work, for example, on fur or faux fur. It's not an area that we've investigated heavily right now. So, and if you think also where we're positioned as well, the product area in our region, so woven shirts, lots of digital materials in this area, knitted tops, cut and sewn knitted tops, and bottoms, sweaters. So even though there are really, really great like digital technologies like Apex to make fully fashioned knitwear, we are still scanning sweater materials to go into clo. Outerwear, so we do quite a lot of different outerwear materials, because obviously making your outerwear garment in clo cuts down on your the cost of sampling is horrendous. Activewear, woven bottoms, and denims. So on denims, we usually do all of the washes, and then all of the post-processing, like all of the whiskering and any of those finishes, get applied in the 3D software by the brand. So I'm going to click through. I'm running out of time, so I don't want to take up too much, but these are just a couple of examples of digital garments. And then I wanted just to finish on the last couple of things, which we are, as a company, Bureau is partnering with the Arts University of Bournemouth, and I think Penny might also be on the call as well. And we're working with the Innovation Studio to offer fabric scanning here in the UK and testing, and then also doing obviously research around the areas of fabric scanning and testing that are not resolved yet. It's a very, new landscape. It's really unresolved. So we're really looking forward to partnering with the Innovation Studio of the Arts University of Bournemouth and working together. That's going to be early next year. Super exciting. And they actually have a huge scope of technologies and capabilities already. We're just going to be like another section for fashion, but 3D printing and all of this 3D machining, 2D cutting and engraving, materials libraries, VR, and they do digital fashion and printing. So obviously, hopefully the scanning and the testing and that happening here in the UK, a public facing service that people can use is going to be really good for the advancement of digital materials. And then the last thing I wanted to mention, which is about archiving, and historical textiles. And I bring this up because these are fashion materials that we're working with, but I think it's really important because this is work that we're doing in Bangladesh. So we're going out for grants to work with different communities in Bangladesh and different types of textile heritage crafts that are, well, usually woven, because we're sort of like specializing in woven materials for this project. So we're looking at the Banarashi weaving, and we're also looking at the Manipuri weaving as well. And these textiles are currently being woven in Bangladesh and around Dhaka, but unfortunately the material knowledge is handed down orally. So quite often, if a person grows old and can't pass down that knowledge because the younger generation maybe isn't taking up that weaving technique, then what's happening is that material knowledge is becoming endangered and then becoming lost. So we're working with those communities to digitize the textiles, use it as an access tool as well to also promote these textiles and heritage textile crafts in the region. It's an area that's very close to Nusrat's heart, and we're also partnering with the Art Foundation that she's a co-founder of as well. And this is all not-for-profit grant work, as opposed to our supply chain work. But I just wanted to mention it in case there was anyone on the call that it chimed with any of their research. So your answer, photograph or simulation. So you may have got it right. Let me find out. I've run this with over about 150 people now. Usually 70% of people know that the simulation, or work out the simulation, is on the right and the photograph is on the left. Let's see. Let me just go to the responses and I will see. I have to just open it. Scroll down. Did you get it right? Did you get it right? Let's have a look. The right 1, 2, 3, 4. Oh, well, 5 people got it right. And 1, 2, 3, and 3 people said the left. So from the people that answered, that was what happened there. But it's really to reiterate that the simulation is made up of 3 parts. So a digital material is made up of 3 parts. It's the appearance, it's the physics, and it's the master data. It's not just an image of the material. As beautiful as that image might be, it is not just the image of the material. Okay, and I think that is me. Yes. So thank you for listening. And if you have any questions, please, I feel free to unmute or ask questions.
Thank you, Gabby. Thank you, everybody, for being with us. It's now your time. Feel free to ask as many questions you want to ask to Gabby. And myself and my colleague Majid will be reading out the questions for Gabby to help her to answer them. So it's your time.
Yeah, any questions at all? Did it make sense?
Yeah, it did make sense. I actually, when I was listening to you and seeing the slides, I was feeling very excited to see all these things. I read about them a little bit. I know about them a little bit, but it's really thrilling to see that you have taken all these out of the page of the books and to the industry and working with the people, the right people here at the upstream in the industry. It's really interesting to see. And can I ask you a question while our participants decide to think about any questions? You were talking. Let's go back to your poll and the image that you were showing, the real photograph fabric and the simulated fabric. Why do you think they are different? What are the main technical things that are causing these differences?
What do you, sorry, do you mean why are they?
Why they do it different? Because both of them are photograph, aren't they?
No, one is a photograph, a physical photograph of a fabric. The other one is the digital material that has been
digital material, but that's been captured either as a screen capture or.
Yeah, it's not a photograph. It's been captured in a 3D environment.
Okay.
Yeah. Right. Yeah. So there are ways of telling them that, there are ways that you can tell them apart. But it's not that I think we get ourselves stuck if we say we can create, and I'm talking about we, the industry, as opposed to we as a company. If we say we can create digital materials that are so perfect, you'll never be able to know the difference between a physical material and a digital material, which is obviously like at some point where we want to get to, but the work that has to go into that is so great, right? And if a brand says, well, we'll only adopt when it's 100% perfect, then no one's ever going to do it, right? Because nothing's ever 100% perfect. So on my side, the reason why we like to ask that question is not to prove, here are two images, one is a photograph, one is an image of a material, which one do you think is a photograph and which one do you think is made in a digital manner? It's not to ask and trick people, it's to say, just because you take a flat image of a photograph or flat image of a fabric does not mean that that is a digital material, because quite often we come up against that in the sense of, I will be working with the manufacturer and they'll have all of these amazing like 3D technologies to make the garment, and then they're putting an iPhone photograph of a fabric on it. And I'm like, you've spent hours crafting the most beautiful pattern and then you're putting an iPhone picture on it. Now, iPhones are fantastic, but they're definitely do not have enough information for you to render a really good 3D garment. That's kind of where it is. But yeah, it's definitely like a learning curve for the industry. And I think the biggest takeaway should be that if you wait for something to be perfect, it will never happen. You know, this is what when you go and work with a new manufacturer, for the brands, if you go and work with a new manufacturer, they don't create the 100% first perfect sample for you straight away. You work on a collaboration, you work with them to get to what you're looking for and your standards, and you build up a relationship and you build up a shorthand of communication. It's the same with digital.
Great, thank you. We have got two questions. Majid, do you want to go first? Do you want to read out one for Gabby?
Yeah, just say hello to Gabby from my side. Actually, I've got a digital background, both industrial and academic. Actually, for archiving print collections. So this is the first time that I'm facing with the fabrics archive. So it was very interesting. And all was fascinating to me. I'm looking for some opportunity to see in person what you're doing. I mean, you're in your lab and your industry. So the whole was very interesting for me. And now a question coming from a person that interested in sharing the recording. Is it? And also, I suppose the slides. Is it possible, Gabby or Evo?
I can see the recording, but maybe I don't know if the slides might be tricky, but I can definitely, well, the recording you guys have, it's not my recording.
Yeah, we are recording it, and yeah, we will put it on our YouTube channel and then hyperlink it with our website as well. And yeah, it could be a good idea to email the link to the participants as well, that we can do easily. We'll do. Slides, it's Gabby's baby. I don't know whether maybe Gabby want to share this with others, but yeah, we will get the recordings from our side. Penelope, thank you, Gabby, for this fabulous presentation. And yeah, we'll be sharing this. And the next question came from Leon. Leon is saying, just curious, do the companies sometimes request substance archive files, SBSAR? I don't know what it is, SBSAR, or do they just want the separate PBR, PNG files like base color, normal maps, etc.?
Yeah, hi Leon. Yeah, we get both requests. Actually, we only have one customer that's requesting the substance files. Most just want the separate PBR files in PNG format at their required resolution. And then some of our customers just want the compiled digital file, because obviously if we just give them the PNGs, that doesn't have any of the physics testing. So we often put them together in a compiled file format, which has all of the maps. Then it has like the backend data, so it's the JSON file format for the U3MAs, or it's the file format, the ZFab file format for CLO. So yeah, it actually depends. So we kind of give out different ones depending on what the customer requires. What's slightly interesting is that everyone's asking for something a bit different, which means that everyone has a slightly different workflow, which doesn't make it easy for us that want to kind of like go in a straight line.
Thank you, just
right.
to make my understanding bit clear, your digitized fabric, it comes with both the texture map as well as the
Physics
fabric
data.
data, fabric physics. So
The physics data, yeah, the physics data, which is specifically for the 3D environment. And that might answer Mary's question, because she said, when you talk about testing, do you mean testing the physical fabrics and then inputting them into the software, or testing digital fabrics? So when we're testing the fabrics, we're testing physical fabrics, and then we take that data and put it into the digital file format, and then package it up. But when I mentioned quality control, I was talking about quality controlling the digital materials. So if I was talking about testing, I meant testing the physical fabric and taking that data. And when I was talking about quality control, I meant quality controlling the digital material in different environments. I hope that answers Mary's question.
And there's another
question
question
from
coming
Mary.
from
Go on,
Mary.
Majid,
So
yeah, she's asking about what kind of test do you do the physical fabrics?
So we have to test so for the softwares, depending on what software you're going into, you have to test the bending, the elongation, the weight and the thickness. But there are different tests depending on the software, because not all softwares require the same data, or they might have their own algorithms, right, for creating the drape of the material. So the testing is slightly different. So they're not test methods that you can necessarily go to SGS, like a testing lab, and go and get them done there currently. So yeah, and then Browseware has its own like testing machine. Clo has a kit. We don't use the Clo kit, to be fair, but Clo has a kit. And then Style3D have their own system. Optitex have their own system. Definitely buy all the technologies to get all the hardware to go with the technologies if you so wish.
Right. Before all these, testing kit came to the market, like browser kit, Optitex kit, or Clo3D kit. We used to use the Kawabata system or the fast technique.
Yeah.
Are they still in use, or?
Yeah, totally. So we'll use the tensile testing machine and a Shirley stiffness tester. Yeah, they're all based on the same. They're all based on the same principles. It's just that the softwares read them differently. Okay. So then, and we don't have all of the testing information for like Optitex and Style3D, like, because we don't work with them right now, so we don't really know exactly what it needs.
Okay.
I'm sure people on the call might.
All right. Okay. Do we have any more questions? No, that's a thank you from Barry's side. Gabby, your digital version of your textile. Are they compatible to all different 3D CAD systems, or you need to tweak every time to export this to different systems?
Yeah, you need to test it in each system. I mean,
Okay.
so we do one file format which goes into Browseware and Optitex. Can't speak for the other softwares, and we do one file format that goes into Clo, because they don't have interoperable file formats. That's the issue. So you can't just do one. You can't just make one material, digital material, and then see it in other systems. Imagine it like, imagine like Word, right? Word doc and Google Docs. Now, it's like they just don't. It's not the same. They just don't read it the same. Fingers crossed in the future, the technology companies will.
Yeah.
Stop the
Or
land grab.
there will be some third-party converter which could convert.
Well, that's what Visu have done with the testing. They've got a third-party converter but that's only between like the three most popular, which is Browseware, Clo, and Style Assist. Browseware, Clo, and Assist. Sorry, yeah, I forget. If I said the wrong
has
name,
now become part of Style3D, if you are aware. So the same company. So I've got a comment from Gadha thanking us. Thank you, Gadha, too, for joining us and making all these session very interactive and fruitful for us.
Yeah, thank you everyone for joining. I appreciate it.
Right, do we have any more questions? No, that's all. Thanking. Yeah, thank you guys. Thank you for being with us. I think it's our time to wrap up. We're almost to the end of the webinar. So thank you, everybody. Special thanks to Gabby for your, very interesting and exciting presentation. I have learned a lot. I have learned a
Oh,
lot.
good. That's the
I
aim.
think it should be the same for the participant, but we might have expert among the participants as well. So feel free to send us your feedback by email. We will, as I said, that we will put the recording on our YouTube channel. I will share the link with you all. Thank you, everybody. Thank you for being with us and have a nice evening. And that's all from our side today.
Thank you very much.